All right, first to graph this problem, we need to see the domain is for x is less than or equal to -2. So we do plug in -2 and we use a solid dot because of the equal sign. So you just substitute -2 in, -2 squared is 4, plus 4 times -2 means -8. 4 minus 8 is -4, minus 5 is now -9. Okay, and then you plug in a few more points. You plug in -3, -4, -5, -6. Okay, so that's the first part of the piecewise function. Next, we have 2x if x is in between -2 and 1. Okay, so we do plug in -2. 2 times -2 would be -4. But then because there's no equal sign, this point of -2 comma -4 will be an open circle. Okay, on the other hand, when we plug in +1, this equals means it'll be a filled in circle. So plugging in 1, 2 times 1 is 2, so the point 1 comma 2 is a filled in circle. All right, then the last piece is simply 3 whenever x is greater than 1. Okay, so 1 itself is not included, so we put an open circle there, but every x value bigger than that has an output of 3. Okay, so at what value or values of x does f of x equal 1? Well, looking at my graph, here's the line y equals 1. So I can tell this happens at 2 locations, here and here. Okay, so unfortunately neither one is an integer, right? It crosses in between the grid lines, so I need to set the equation equal to 1. I'll start with this piece. So this piece came from the middle function, so I want 2x to equal 1. Okay, so just divide both sides by 2, and I get one answer of x being 1/2 or 0.5. Now I need to figure out where the parabola piece equals 1. So the parabola piece's equation is up here. Okay, so again, I want the output of this piece to equal 1. Okay, so I would just subtract 1 from both sides. Okay, so unfortunately the resulting quadratic is not factorable, so I'm going to choose to use the quadratic formula. Okay, 4 squared is 16, and then -4 times 1 is still -4 times -6 is +24. Okay, now radical 40 can be simplified because this is equal to radical 4 times 10, or radical 10, and then radical 4 is simply 2. So radical 40 can be replaced by 2 radical 10, and then now I can reduce because all 3 terms are divisible by 2. Okay, so it's really -2 plus or minus radical 10. Okay, but that's 2 answers, and I can see on my graph that the quadratic only gets hit once. So I know that if the domain didn't get cut off, the quadratic would go back up here, and there would be a second intersection over here. But because I cut off the parabola by the domain, I only have the solution on the left. Okay, so if there's 2 solutions and I want the left one, that must mean I have subtracted the radical, not added. Okay, so the other solution is -2 minus radical 10. All right, so for letter B, now I want to know where is the function output less than or equal to -6. Okay, so -6 is right here. So I only care about this section of the graph, the part below -6. Okay, so this side is easy. It lands on the integer value of -2. So I know that it stops being below -6 at -2. And I do put the bracket because -2 is included. But now, how do I find this starting point? I'm going to have to set the function equation equal to -6. Okay, so x squared plus 4x minus 5 equals -6. Okay, so add 6 to both sides. X squared plus 4x plus 1 equals 0. So again, from here, it's not factorable, but you can do completing the square or quadratic formula. Okay, so I've already done it. So you'll get, after you've simplified your radical, -2 plus or minus radical 3. Okay, but again, this is two answers. We see that the parabola only gets hit once. So again, we know that the parabola would get hit a second time over here if we drew the full thing. But because we only drew the left section, we know that this is the minus side and this is the plus side. So we must use subtracting the radical. So the starting point is -2 minus radical 3. And then because the inequality includes the equal sign, this point itself is included, so I use a bracket. Domain, what x values are allowed? Well, looking at my graph, I hit all values to the left over here. At -2, I jump up to this piece without skipping anything. And at 1, I jump to this piece without skipping anything. So all real numbers. All right, now the range, what y values do I hit? So starting at the bottom, the first value I hit is -8. Oh no, I'm sorry, that's -9. And I do actually hit -9. It's a filled in solid circle, so I use the bracket. And then just using this piece, I can see that I can go upwards forever. So I never stop. All right, write the piecewise function. So I'll start with this linear piece. It's a straight line, so it's clearly linear. Okay, the arrow means it goes forever to the left. But then the open circle at -2 means x has to be less than -2. Okay, so now what's the equation of this piece? Well, if I imagine it continuing on, I can see that it would have a y-intercept of 4. All right, so what's my slope? Well, if I just pick 2 points which are clearly on the grid, in order to go up 1 square, I have to go to the right 2 squares. So my slope is 1/2. Rise over run. Okay, so now the middle piece. The middle piece has a filled-in circle at -2. And it continues until the filled-in circle at x equals 1. All right, so now to get the formula for the quadratic, well, you can make a table of values. So -2, 5, -1, 2, 0, 1, and 1, 2 are all points on the parabola. Okay, so finding my first difference, not linear, but then second difference is 2. So it's a constant second difference, so it is quadratic, but I remember that a is half of the second difference, so a is 1, meaning it's just x squared. Okay, the y-intercept is 1, so that means the c is 1. Okay, so what about maybe a b value? So I already know it's x squared plus bx plus 1. So let me plug in the point 1, 2 on the parabola. So when x is 1, y should equal 2. Okay, so 1 plus b plus 1 equals 2. I get b plus 2 equals 2. Well, if b plus 2 equals 2, subtract 2 from both sides, b is 0. So b goes away, so it's just x squared plus 1. All right, and then lastly, I've got a straight line which starts after x is greater than 1. And the output is simply a constant 3. Okay, g of negative 2. So when x is negative 2, what is the function at? Well, I can see from my graph that at negative 2, the filled-in circle is at positive 5. This was an open circle before I started drawing. So that's why it's not 3, it's just 5. Or if you're not sure, you can look back at your setup. Negative 2 does not fall into this piece because it doesn't have an equals, but it does fit into the middle piece. So you would plug negative 2 into your middle equation. So instead of x squared, it'd be negative 2 squared plus 1 becomes 4 plus 1, which is 5. Okay, for what value or values of x does g of x equal 1? So let's just g of x, remember, is the output, the y value. So if we draw in y equals 1, we see it hits in 2 places, here and here. Well, luckily, both of those are on the grid. So at negative 6, the function graph is at 1, and at x equals 0, the function is also at 1. All right, so for what value or values of x is g of x greater than 4? Okay, so let's draw that in. 4 is up here. Okay, so I can see that the only section which is above 4 is right here. And this is all the quadratic, right? I don't need to worry about the linear or the straight line. I just need to worry about the quadratic. Okay, so I know that the highest it can go is at x is negative 2. So that's my leftmost point, so that's my starting point. But unfortunately, to find where it stops being above this y equals 4, this point is not on the grid, so I need to find it. Okay, so I want to know, where does this quadratic piece, x squared plus 1, where does it equal 4? Okay, so subtract 1 from both sides. Okay, so here, because there's no x to the first power, it's easiest to just square root both sides. So remember, when you square root, you create both positive and negative solutions. But for this quadratic, again, if I imagine it going on forever, there would be the second solution over here. But because I cut it off, the only solution, the only intersection is right here, which is obviously on the left. So that must be the negative version. So I don't want positive 5. I want radical 5, excuse me. Oh, sorry, this should have been 3. 4 minus 1. Okay, but then the next step is the same. You would square root both sides, so you would get square root of 3. And because the symbol does not have the equal sign, I use the parentheses, not the bracket. Okay, so one more time. I set the quadratic piece equal to 4, subtract 1 from both sides, get x squared equals 3, square root both sides, get x equals plus or minus radical 3. But because I only have the left part, I know that this is negative, not the positive root. So that's why this is the range of values. All right, so for 3, if Josh buys less than 100 pounds of potatoes, the cost is $3 per pound. Okay, so if x is the number of pounds, then every single pound costs $3, so you would multiply x by 3. Okay, so then thing is, this is only true for x is less than. Okay, but you also have to consider, for a word problem, a real life example like this, if x is the pounds of potatoes, it doesn't make any sense for him to order negative pounds of potatoes, right? So that's why we need to say that x can't go below 0. Okay, because again, if Josh buys -5 pounds, 3 times -5, -15, does it cost him -$15? No, it doesn't. So that's why we need to set a second requirement for the domain. Okay, so then the other part of this problem says if he buys 100 pounds or more, so that means exactly 100 fits this second situation. So it's not just greater than 100, it's greater than or equal to. And now it's $2 per pound. Okay, graph the floor function. Okay, so I'm going to make a table of values. So I'm just going to start with 1. Okay, so when I plug in 1, that's 2 of floor of 1 plus 2. Floor of 1 is still 1. 2 times 1 is 2 plus 2 is 4. Okay, so 1 comma 4 is a point. Okay, so it's a filled in circle. This is a real point. So I know that step functions will either go to the left and have an open circle or go to the right and have an open circle. So how do I know which one it is? Well, let me try a decimal. Let me try 0.5. Okay, so when I plug in 0.5 for x, floor of 0.5 is 0. 2 times 0 is 0, plus 2 is 2. Okay, these 2 points are not on a step. They are not horizontal with each other. So let me try something a little bit to the right. Okay, so let me try maybe 1.5. So when I plug in 1.5 for x, so now 1.5 rounds down to 1. 2 times 1 is 2, plus 2 is 4. Okay, so these are on the same level. So that must mean that from my starting point, I must go to the right. And then I know that it ends in an open circle. Okay, so that pattern must continue, right? So when I plug in 0, floor of 0 is still 0. 2 times 0 is 0, plus 2 is 2. So that's the solid point. And I know from here, my step goes to the right and ends in an open circle. Okay, and I can also see that I skipped 2, which makes sense because of the a value of 2. So I can now continue the pattern without needing any more points. Right, I go down another 2 and shift 1 space to the left. Right, down 2, 1 space to the left. Okay, what sequence of transformations occurred? Well, the 2 in front is a vertical stretch. But there's many different vertical stretches, so you have to say by what factor. Okay, and then the other part of this is the k value because it's being added or subtracted outside of the x. So this is a vertical translation. Okay, so 6, these are just definitions. We know that linear functions have a common first difference, quadratic have a common second difference, and exponential have a common ratio. Okay, so 7. Okay, so again, I always like to choose numbers, like actual numbers, not variables, to help visualize the situation. Okay, so let's pretend that the math department needs 1,000 sheets. Okay, well, if each ream is 500, how would I figure out how many reams I need? I would just divide 1,000 by 500 and see that we need 2. Okay, so let's try a number that doesn't work out as nicely. Let's try 1,800. Okay, so I already know that I need to divide the total number of sheets by 500 each. Okay, so this one turns to 3.6. Okay, well, the store is not going to sell the math department 3.6 groups of something. So if the math department has to buy, they would rather buy too much than too little, right? Because if they buy only 3, that would give them 1,500. They would be 300 sheets short. So we have to round this up to 4. So that tells me I'm doing the ceiling function. Okay, so again, you take x and you divide it by 500 sheets per ream, but then you round it up, which means you do the ceiling function. All right, so for 8, admission you only pay once, so that's a one-time fee, but then every single ride costs $2. So since if you go on X rides, X times $2 each means you pay 2X dollars for the rides plus the $5 one-time admission fee. All right, so 9, let's make a table of values. They said initially, so at time 0, it's 40 away from normal. After 1 hour, it's 20 away from normal. 2 hours, it's exactly normal. 3 hours, it's 20 away from normal. Okay, so if we quickly sketch a graph, it would look like this, which looks like an absolute value function. Okay, and this point is 2, 0. So I know that because the vertex got shifted from its normal 0, 0 to 2, 0, there was a horizontal translation of 2 units. And now I need to find the slope. So I'll just take these 2 points that were given to us and use the slope formula. y2 minus y1 over x2 minus x1. So I'll call this x1, no, I'll call this x2 y2, and I'll call this x1 y1. So that becomes 20 minus 0 over 3 minus 2 becomes 20 over 1, or just 20. Okay, so this tells me the slope is 20. All right, here, let's make a table to represent the situation. It says on the first level, so on level 0, it's just Johnny. On the first level, he's required to get 2 people to join. Second level, we need 4 people to join. Third level needs 8 new people. Okay, so what's the change? To get from 1 to 2, you do times 2. 2 to 4 times 2. 4 to 8 times 2. So since there's a constant ratio, this one's exponential, which looks like this. So A is the initial value, which when x is 0, the initial value is 1. And B is the constant ratio, which is 2. Okay, so the 1 in front doesn't really affect anything, so we don't need to write it. Okay, so again, for these types of problems, let's just choose some numbers. So let's say that Lily has $12. Okay, so if each toy costs $5, you would divide by 5. So that would be 2.4. Well, unfortunately, that means she can buy 2 toys and she'll have some money left over, right? The store is not going to round up and let her buy 3 toys if she only has $12, because 3 toys would cost $15. So that must mean that we round this down. So we're doing the floor function. All right, 12. So looking at my y values, which first of all, the input, which is t this time, is counting by ones. So 80 to 96 is plus 16. 96 back to 80 is now minus 16. 80 to 32 is minus 48. Okay, so it's not linear. Let's check for quadratic. 16 to negative 16 is minus 32. Negative 16 to negative 48 is also minus 32. So constant second difference means it is quadratic. So we've already got A. A is half of the second difference. So half of negative 32 is negative 16. And we've got C,